Hello students, we will begin the problem solving session. Already we have finished I think 6 problems, 1, 3, 5 and 8 and 11. I think that till that we have finished 1, 3, 5, 8, 11. Right. Now I'll start in the reverse order. So this is the last problem. The question is, find the volume of parallelepiped whose three coterminous edges are described by the vectors I plus 2j, 4j and j plus 3k, correct? And you need to find what is called as volume of parallelepiped. What is the formula for volume of parallelepiped? It is STP or A dot B cross C. How do you write this A dot B cross C? In a determinant where ax, ay, az, bx, by, bz and cx, cy, cz. So this is my ax coordinate is 1, 1i plus 2j plus there is no k, so 0. As far as this vector is concerned, I, there is no I, this is 4, this is 0. As far as this vector is concerned, I is 0, b is 1 and c is 3. Right. So after writing this determinant, our next job is to check 1 into 4 3s are 12 minus 0, 1 into 0 plus 2 into 0 into 0 minus 0 into 3 plus 0, don't have to write anything. So which means answer is 12 units. This is the answer for volume of parallelepiped whose edges were given with these vectors I plus 2j, 4j and j plus 3k. Right? We'll move to the next problem, which is question number 31. Prove that A cross B dot C cross D is equal to A dot C second bracket B dot D minus A dot D into B dot C. This will have to show that or prove that, right? So in doing this, we'll have to consider first the LHS. What is the LHS? A cross B dot C cross D. Now what will I do? I'll change this cross and dot product. So I'll write A dot B cross C cross D. So I changed my order from C, instead of C cross D bracket, I put the bracket for B cross D. Correct. Now I have to use the usual formula what I use for this method. Correct. So that formula is what I used earlier for A cross B cross C. We'll convert that for B cross C cross D. So this will be nothing but B dot D outside the bracket C minus B dot C outside the bracket D. This is the formula for B cross C dot D cross D. Correct. So using this formula, what we can write then? A dot is a dot product. So A dot C in one bracket, B dot D as it is, minus A dot D, this A dot D, correct, and in other bracket this as it is, and you are reached to the RHS. Right? At times this question is asked for a 5 marks where there is hardly anything to do. Only I changed this cross and dot product, and this identity is well known. So once you know this, there's just a two-step answer to fetch 5 marks also. Correct? So after doing 35 question and 31 question, we'll go back in the reverse order. So next question I'll solve, which is question number 27. Question number 27 says, show that the filled vector v is 2xy minus z cube I plus x square j minus 3xz square plus 1 times k is conservative. This we have to prove. Correct? To show the conservative, what is the rule? Show del cross v has to be 0. If it is not 0, it is not conservative or rotational. Correct? That is the same logic we'll have to show. So if del cross v comes out to be 0, that's our job. So to show that, I'll write I double by double x 2xy minus z cube j double by double y x square k double by double z minus 3xz square minus 1. Right? After finishing this, we'll have to simplify. So I inside the bracket double by double y minus 3xz square minus 1. There is no y term, so it will be 0. Minus double by double z of x square. Right? So I into this minus this, there is no term, so this will come out to be 0. Plus j double by double z of 2xy minus z cube minus, we are writing j double by double z of this, right, minus double by double x of minus 3, I write it over here, 3xz square minus 1. So I will put a bracket over here, right, plus k double by double x of x square minus double by double y of 2xy minus z. Right. So I finished with all the terms. As far as this term is concerned, there is no y, so it will be 0. Here there is no z, so 0. As far as this term is concerned, we have the answer 2xy minus z cube. So it will be minus 3z square. Right? Second term, double by double x. Here there is x, it will be 1. This is minus sign. This is also minus. We'll have to make plus 3z square. Right? Plus k double by double x of x square will be 2x, and this will be double by double y of 2xy will be 2x. Correct? This gets cancelled, this gets cancelled. It's 0. Therefore, we can say confidently that the curl of v comes out to be 0 without having any problem. Correct? Next question, after 27, we'll go to 25. Question number 25 now. So 25 is show that del of 1 by r is minus r by r cube. Right? So we'll have to show that how you are going to get del of 1 upon r is minus r by r. So first job is del. So what is del? So we will say LHS. I dabba by dabba x plus j dabba by dabba y plus k dabba by dabba z of 1 by r. To that I will write 1 upon under root x square plus y square plus z square. Right? Why? Because we are mentioning r to be xi plus yj plus zk. Right? Then with this logic I have to do first dabba by dabba x of this, then j and then k. So I'll write I dabba by dabba x of 1 upon x square plus y square plus z square plus j dabba by dabba y of 1 upon x square plus y square plus z square plus k dabba by dabba z of 1 upon x square plus y square plus z square. Right? So if you simplify this, what you will get is 1 upon under root x square plus y square plus z square. So that will give you half, correct, into that same term raised to 3 by 2 into dabba by dabba x of 2x square will be 2x, correct. So all that terms put together I can write what is called as minus half into 2x for x square into 1 upon x square plus y square plus z square raised to 3 by 2 plus j, same logic, minus half into 2y into x square plus y square plus z square raised to 3 by 2 plus k minus half into 2z 1 upon x square plus y square plus z square raised to 3. So cancel this 2, cancel this 2 and cancel this 2. Right? So this will give me I minus x, or I can say minus xi minus yj minus zk divided by x square plus y square plus z square raised to 3 by 2. Correct? What is xi plus yj plus zk? It is r. So I can write minus r, and what is this? R square raised to 3 by 2. So cancel this. So you get minus r by r cube, which is your RHS. Right? So del of 1 by r. Del is differential operator. So I dabba by dabba x plus j dabba by dabba y plus k dabba by dabba z of r. We have got this simple possible answer. So after completing question number 25, I will go to question number 22. 22 says, determine the constant ABC such that the vector v x plus 2y plus az times I plus bx minus 3y minus z times j plus 4x plus cy plus 2z times k is irrotational. Is irrotational, right? So here we have to prove del cross v equal to 0. Then we will be able to get these values of A, B, C properly. So to do that, I will have to write del cross V is equal to I dabba by dabba x, and here it is x plus 2y plus az, j dabba by dabba y bx minus 3y minus 2 minus z, minus z, and here it is k dabba by dabba z 4x plus cy plus 2z. Right. After doing this, we have to just simplify. So I inside the bracket dabba by dabba y of 4x plus cy plus 2z minus dabba by dabba z of bx minus 3y minus z plus j I have to write dabba by dabba z of x plus 2y plus az minus dabba by dabba x of 4x plus cy plus 2z plus k dabba by dabba x of bx minus 3y minus z minus dabba by dabba y of x plus 2y plus az. Correct? So if you simplify this, what do you get here? This is dabba by dabba y, so this c will be there, this c. Right? So I times, I got only c in the first bracket, minus here what will I get? This is minus dabba by dabba z of z will be 1, so minus 1, so this will be plus 1. Dabba by dabba z of minus z will be minus 1, but this sign makes it plus 1, plus j dabba by dabba z of az will be a. Here there is no z, no z, here it will be a. In this case, dabba by dabba x of 4x will be 4, rest of there is no x, plus k times, here there is dabba by dabba x of x is 1, so b, and here it will be 2, right, has to be 0. This means what? C has to be minus 1, A has to be 4, and B has to be 2. Then only we can say 4, 2, minus 1. Then only we can say that the given vector V is irrotational. That's what is the meaning of question number 22. So after question number 22, we'll go to question number 20. Question number 20. Question number 20 says, if vector A is x square z times I plus x y square z times j minus 3y z square k, determine curl A at the point 1, 1, 1. Determine the value. So here what is done? You have been given a vector A and you have been just asked to find simply curl of A at a given point. Right? What is the first step? Write the determinant. Right? What is determinant now over here? curl of A is I dabba by dabba x square z j dabba by dabba y xy square z and k dabba by dabba z minus 3yz square. Simplify further, so you get I dabba by dabba y of minus 3yz square minus xy square z plus g dabba by dabba z of x square z minus dabba by dabba x of minus 3yz square plus k dabba by dabba x of x y square z minus dabba by dabba y of x square z. Simplify this. So in the first term, y will be y will be 1, so we have I inside the bracket minus 3z square. Correct? Here what we have, z is 1, so minus xy square plus j times, here it is x square and here it is minus plus, but there is no x term, so only x plus k times, here it will be y square z minus then nothing, so because there is no y term. Right? Now after getting the answer, put the value x, y, z to be 1, 1, 1. So you have minus 3 minus 1 plus j into 1 plus k into 1. So minus 4i plus j plus k is my curl of A answer at the given point 1, 1, 1. Correct? Minus 4i plus j plus k. After finishing 20, we will go to equation number 19. Question number 19 is, determine the constant p such that the given vector v is x plus y times I plus y minus z times j and plus x plus 2pz times k is solenoidal. This we are done in theory. Right? To show this solenoidal thing, we have to show divergence of V has to be 0. Right? So, to do that, what I am going to write? I dabba by dabba x plus j dabba by dabba y plus k dabba by dabba z dot x plus y times I y minus z times j x plus 2pz times k. Again, like yesterday we did, I dot I, j dot j, k dot k is 1, other terms will be 0. Correct? Taking that into account, what will we get over here? Dabba by dabba x of only this term. Dabba by dabba x of x will be 1 plus dabba by dabba y of this term, y minus z, only y, so plus 1. And as far as this term is concerned, here we have 2p, so z will be dabba by dabba z of z will be 1, so plus 2p will be 0 because that is the condition. So what does this give? 2 plus 2p will be 0, which means 2 is equal to minus 2p, so p has to be minus 1. That's what the simplest argument as far as showing the given vector v to be solenoidal is concerned. Correct? Then we'll move to question number 18 now. After 19, we'll go to question number 18. Question number 18 says, show that the vector A is equal to 2x square plus x y square z times I plus 3x cube y minus 3xy times j minus 4y square z square plus 2x cube z outside the bracket. K is not solenoidal. Is not solenoidal, which means we should not get divergence of A need not be 0. We should get some answer. That's what is the logic behind showing not solenoid. Right? So what is the first step? Divergence of A is equal to I double by double x plus j double by double y, the full term. 2x square plus 8xy square z times I plus 3x cube y minus 3xyj minus 4y square z square plus 2x cube z. That vector will come over here. So we just want double I dot I. So what will I write? Double by double x of 2x square plus 8xy square z plus double by double y of 3x cube y minus 3xy, right, plus double by double z of minus 4y square z square minus 2x cube z, right. So if we simplify this, 2x square will be 4x. Here it will be 8y square z, correct, plus double by double y of y will be 1, so it will be 3x cube. Here it will be 3x plus double by double z of this term will be 4 2s are 8 y square z minus 2x cube, right. So with this logic, we have to just check what gets cancelled. This is 8y square z, this is minus 8y square z. This is 3x cube, this is 2x cube. So what is left is 1x cube. Okay? As for this is 4x, this is minus 3x, so we get plus x. So this is the answer, right? The vector value of del dot A is not 0, is something, which means this is not solenoidal, that we have proved. Right? After this, we will go to question number 17. Question number 17 says, prove that the vector A solenoid. Vector A over here is 3y to the power 4 z square times I plus 4x square z square times j minus 3x square y square k. We have to show it is solenoidal, so the value has to be 0. Right? Again same, divergence of A is equal to I double by double x plus j double by double y plus k double by double z dot the given vector. Correct? So here again I dot I value will be there, j dot j and k dot k value will be there, remaining terms will be 0. So I will write double by double x of 3y to the power z square, correct, plus double by double y of 4x square z square plus double by double z of minus 3x square y square. Here there is no x term, so answer is 0. Here there is no y term, answer is 0. Here there is no z term, answer is 0. So we can say that the given vector is solenoidal very clearly. Now comes question number 16. Question number 16 is again very simple. V is given out to be y square z times I plus xz times j plus 3z k. You have to find del dot v. Right. So del dot v will be I double by double x plus j double by double y plus k double by double z of the given vector xzj plus 3zk. As far as I dot I is concerned, right, double by double x of y square z, so 0. Double by double y of xz will be 0. But double by double z of 3z will be 3. So this implies divergence of v. The answer is 3. As simple as possible. Right? We'll take hardly one problem now. So next is question number, we'll see 14. Question number 14 says, determine a unit normal to the surface. Surface means phi. What surface given to you? X square plus y square plus z square. Correct. At the point, what point is given to you? 1 minus 2, 3. Correct. So in solving such problem, what we have to do basically? You need to find del phi first. That is the first one. Correct. So in finding this del phi, you need to first check it out how you are going to get the value clearly as far as the problem is concerned. So over here, our first job is to get del or grand phi, I should say.